So thank you everybody for joining us today. Welcome to our Split webinar, Stay Humble or Be Humbled. Today you're going to have myself, Maddie. I work on the marketing team here at Split, and I am being joined today by the lovely Anthony Rindone. He works on our product team for on our experimentation. So he has given this talk a few times. It's really awesome. He's going to be going through some case studies from the trenches in experimentation. We're going to have some time for a little bit of Q&A afterwards. So if you have questions as Anthony is going through his talk, feel free to just drop them into the chat box. I will be running through them towards the end. And we will also be making sure that everybody gets the slides and a recording of the webinar today. So feel free to kind of kick back. Don't need to take notes or anything. You'll be able to have all of the information sent to you afterwards. But with that being said, I am going to hand it over to Anthony, and I'm going to let him take the reins.
All right. Thanks for the introduction, Maddie. I also appreciate the ego boost on saying that's an awesome talk, particularly because one of my motivations for this talk, so I'll start off by mentioning that I'm on the product team responsible for the experimentation platform at Split, but I only joined in July. Before this, I have over a decade of experience running literally hundreds of experiments, either managing them, analyzing them, helping clients launch them. And one of the motivations for this talk was that through those hundreds of experiments, every time I think I know what's going to happen, or every time I think I have a grip on how users are going to behave, I'm proven wrong time and time again. And so I kind of wanted to crystallize some of those thoughts into this thesis that product development teams should remain humble. Otherwise, you're going to be humbled by your users. And so some of the, we only had time for maybe 2 or 3 case studies, so I put them together in one deck. But if you wanted to reach out to me afterwards, and maybe we could always talk, I'm always happy to talk more case studies on experimentation. You can reach me at my email below here, anthony.rindone@split.io. So overall, one of the things that motivates not just myself, but the whole team at Split is how we can make better decisions from a product marketing operations standpoint, but then also what does it mean to make better decisions, and how would you know? These are pretty tough questions that if it was easy, you wouldn't need product teams, you wouldn't need operations teams. You would just know exactly what to do or where to make your bets. But ultimately, it comes down to one of the theses that we have at Split is that you need to guess less and test more. And like I mentioned before, I've done about like literally hundreds of experiments, maybe even close to 1,000 if I really wanted to do inventory. And I bring that up because I like using the analogy of baseball. And if you're not from the States or have no experience with the sport of baseball, ultimately the game is driven by the batter who's at this plate, and the pitcher has to throw them the ball. And the game only moves forward if they hit the ball, and ultimately you either succeed or you fail, you get an out. And over the course of 160 games or more in a season, you're considered really good. In fact, you're considered world class if you can succeed 30% of the time. So if you get a hit 3 out of 10 times, you're considered world class. But when you really think about it, that means you fail more often than you succeed at baseball. And I found that funny enough, that average of 30% roughly translates to the success rate of product experiments across any vertical, across any part of the funnel. Ultimately, 3 out of 10 experiments roughly are going to perform as good, if not, or we'll say perform just as you would expect. Now, given that, one of the things that we try to recommend or push for our customers is this concept that any change you make is going to be its own feature, and every feature should be thought of as an experiment, because you don't really know what's going to happen. You think you might know, but as we go back to the baseball analogy, more often than not, you're probably wrong. Why that might be? whether or not that's because of the wrong or the bad analysis coming in, or not having enough data, or looking at the data wrong, or even just like random circumstance, I think is why product managers have a job, right? But also why I have some case studies to provide here today. Nevertheless, this isn't going to be a clickbaity, follow these 3 steps and you'll succeed. Rather, I am here to tell you that this is a hard thing to do. Making decisions in the face of uncertainty and risk is hard. And that's okay. Like I said, if this was easy, all you would need is a step-by-step checklist and you'll be good to go. But we can at least learn how to ask the right questions and get better over time and maybe improve on that 30%. So for your org or for your team, it'll be closer to 40% or 50%, maybe even better. So with that said, I'm going to focus on 3 different case studies that will kind of have these 3 conclusions at the end. So if you need to like print something out or take something away from this whole presentation, if you fall asleep from here on out, these are 3 things to remember. Number 1, focus on the bigger picture. Sometimes we get sucked into a vacuum and focus too myopically on one piece of the puzzle. You need to step back and think bigger. Number 2, like I said, systems thinking is not easy. So even though we need to step back and look at the big picture is very complicated. And so I have one of my favorite case studies in my entire career is right in the middle here, talking about the systems thinking part and demonstrating why it's not really easy. And then lastly, why are hypotheses important? They're more than just a guess. And so I'm going to suggest a small framework of sorts to help you build good, precise, falsifiable hypotheses. I think sometimes the hypothesis step gets skipped a lot in experiments or even just feature releases, partly because I think folks haven't learned what it means to build a good, precise hypothesis. And so I have some recommendations here at the end that we can talk about. So with that said, we're going to go way back and start off with my first job as a product manager working on an e-commerce mobile app. And going to walk through an interesting test that many of you may have seen or maybe even have run yourselves. And so to demonstrate this case study, I'm going to give an example of this website, this e-commerce site called Fun Veritas. And so you look on your phone, you're on a product, we call this the product detail page, or if you're in e-commerce, you know it as the PDP. And we have an analyst who comes in and mentions that native app users convert at a higher rate than mobile web users, so we should push users to the app. It's a very common analysis that multiple e-commerce sites would recommend, and many of you probably recommended it yourself. I think you could talk about whether or not folks downloading the app are more likely to be already fans of yours or fans of your site, hence why they're downloading the app, and that's why they convert at a high rate. But that aside, we'll pin that discussion for now. And we're coming to this goal of, all right, well, how do we push users to the app? Well, the most obvious way, or at least one you'll see most often in the industry, is to do these app install ads, where you'll kind of take a little space at the top, a little bit of real estate. You kind of hide some of your product, but you're pushing the app and you're suggesting, hey, download our app or install our app. And so this is, again, something that I started off doing for one experiment. And compared to those who didn't see the app install ad, we noticed that straight up 15% increase in app downloads over the course of 2 weeks for running this test. Now, being the troublemaker that I am and wanting to see how far I can push this, I suggested, well, let's add another one. Not make it bigger, literally add another one to see what happens. And we noticed that compared to baseline, after another 2 weeks, we saw a 25% increase in app downloads. And of course, again, because I wanted to really push the limits on how far this can go, I'm sure you could see where this is going. We saw a 45% increase in app downloads versus baseline. And baseline here being that you don't see any of this. So now not only are we seeing increasing app downloads per every extra ad, but now we're starting to get a nonlinear increase. We go from plus 10%, 15%, 25%. Now we're adding 20% from 25 to 45. Now this is good, right? As many of you can see, or as many of you can guess, this probably might not be the best thing to just focus on app downloads in a vacuum. So we went back and asked, well, what other things, or what else are those users doing? What are users doing in baseline who saw the ad or who did not see the ad? And what are users doing who downloaded the app and then proceeded to use the app, among other things. And we noticed that people who saw the ad but didn't install, they tended to bounce pretty significantly. We noticed that bounce rate being those who visited this page and then immediately left the site. They tend to, the rate at which they were bouncing doubled. And we had a pretty significant loss in revenue. Even though the app caused users to convert more, that was the original hypothesis, pushing so many users to the app, we noticed a 15% drop in revenue month over month was not the right investment. So what's the learning here? What should we have done differently? And so this gets back to point number one, the anti-pattern, focusing too much on one metric. The better solution would be to test with multiple key metrics. So not only have app downloads, but have some sort of guardrail metric like revenue. Or step back and have a broader analytics model. So maybe you're looking at engaged users or daily active users or something along those lines. And I'll stop there. I guess, Maddie, we're doing questions at the end, right?
Yep.
Yeah.
I'm just collecting them and then we can go through them at the end.
Okay, cool. So stepping into case study number 2, this again, I mentioned before, is probably one of my favorite case studies to talk about. And this was involving a newsfeed algorithm change. So this was a bigger test. So imagine 5 variations versus 1 control group. And we're looking at, if you imagine like a news feed, it doesn't necessarily have to be Facebook posts or Twitter posts. It's really anything where you see a linear feed of content. And we changed the algorithm to provide different suggestions on what you see or different ordering of what you would see when you visit the news feed. And so the primary metric when we created this test was click-through rate in the top 10 items in the first 2 sessions, meaning that ideally the right algorithm, at least our hypothesis was the right algorithm would rank the things you would care about sooner, and therefore you would have higher click-through rate earlier, rather than needing to scroll through to the bottom. Now, per the previous recommendation, we also looked at some other metrics, namely conversion rates, user engagement. And you can look at engagement in many different ways, but some of my favorites are pages per user, sessions per user, time of engagement or duration per user. But for now, we're going to graph and look at just click-through rate in the top 10 items in the first two sessions. And we graphed this for 2 weeks. Now, as a warning, this was back in 2016. So looking at it again in 2020, I can only adjust the graph so much with resolution. So excuse some of the funky colors. But what we graphed was if you have red as control normalized at 0, and you graph for each variation is a different color, what's the percent change versus control for every single day, you kind of get a graph like this. And so we started the test on March 7th, 2016. And after 2 weeks, roughly around 3/21, we started looking at the data. And we noticed that, again, if red is control, we have 2 variations that are performing worse than control. Like let's say minus 0.7%, minus 1% below control, roughly. Most likely not statistically significant, but we'll pin that for now. And then some of the other variations, but 3 other variations are looking like they're doing pretty well. They start out pretty funky. We'll say that's novelty effect. But then they kind of come out pretty high and seem like they're doing a lot better than control. And so as I'll mention that, well, we tried to figure out, well, which one do we pick? Well, as we decide when we'll have engineering work on this, we'll let the test run and collect more data as we can kind of free up engineering time to launch the winner. And we noticed that as we were following the data, all the variations started pulling below control. And this is bad. Because now when we have engineering resources freed up after, let's say, a month of testing, we're stuck with the question of, well, which one do we launch? Why did you waste our time? But then again, we didn't launch the wrong one, so that's also good. But what's going on here? So we step back and try to figure out, well, what would be some of the drivers for causing some of these funky trends that seem like they're doing well at first, but then caused a negative click-through rate over time once you let the data continue to come in. And what we looked at, or where we found the issue, or what we think is the issue, came up in traffic trends. And so what we graphed here are 3 different trends, but you don't really need to care about too much of the exact y-axis here. Just know that visits is in purple, the number of visits to the site for every single day. The number of assignments, you could think about that would be the number of visits assigned to your test. So in this case, you would expect them to be pretty close, because if we're a newsfeed product, you're logging in, and that's pretty much the first thing you're going to see usually. But it's not necessarily 100%, because if you log in but never visit the newsfeed, you'll never be in the test. So that's the way to think about that graph. And then the percent counted is kind of that ratio. And what we noticed over time is that the visits to our site was not flat, or the visits to our site were not flat. In fact, seems like there's a middle point around March 20th, March 23rd even, where visits started to creep up a bit. And they started to continue to creep up over time. So of course, we had to see if they lined up. And you notice that, it turns out that they did. Around this March 20, March 21st timeframe, as something was causing visits to increase, while at the same time causing click-through rate to decline, or at least click-through rate across the board in our variations. Now, when we further investigated, we noticed that the visits to the site were driven by a marketing campaign, which was pushing a bunch of users that, for whatever reason, were just not responsive to our algorithm, but also the algorithm wasn't trained on those users. Now, the AntiPaddling here is not precisely and/or defining or not understanding our user enough. And the better solution would have been to test more frequently, because going back to the original point about the marketing campaign, that's going to happen. There's no way to necessarily control for every single factor coming into the test. And that gets to my point about this case study, that systems thinking is hard because you can't control everything. So how do we control for, or let me step back and reframe the question, because I was going to say, how do you control for reality? But that doesn't make sense. But how do you accept the fact that there are going to be a lot of changes to your product that you can't necessarily control, but you need some way to evaluate whether or not you're making the right decisions? And at least my recommendation, others might have different approaches, but my recommendation is to test more frequently. And in fact, with more precise segmentation. So in this case, could we have tested a different algorithm for users coming in through a specific marketing campaign, or specifically from email marketing, versus folks coming in from direct, or folks coming in from, I don't know, some other source, rather than try a one-size-fits-all approach? Now I'm going to round out this with a case study around checkout flows. And so let's say we're testing this, going back to a basic A/B test. So we're doing a change to the checkout flow. And based on this test, we have the question that every product manager needs to ask, which is, should we go with the new flow? Which one's going to make us more money? So let's say we have two analysts trying to answer this question. Analyst one looks at the test, and specifically, we're measuring ARPU, or revenue per user. I particularly like this metric, not only because revenue per user is a overall good conversion rate metric, or a good guardrail metric to conversion rate, but also it's fun to say ARPU. And so we asked analyst one, they compare test versus control, looking at 95% confidence, or standard t-test, and answers, well, yes, test looks like it's doing better. Because over the course of this experiment, the test group had a higher revenue per user by a statistically significant margin, particularly 95% confidence. Pretty by the book answer, love it, super simple, as concise as can be. Analyst two comes in, looking at the same data set, the same spreadsheet even, because again, this is a real case study, and segments by device type. And notice something a little bit strange here. And in a course of debate mentions that this can't be right because for every single device type, the control group had a higher revenue per user. And if you're anything like me, or if this is the first time you're seeing this type of case study or this type of scenario, you're probably having a similar reaction I had, which was very confused, doing the math. There's got to be something here going on. But again, these are two analysts looking at the same data set, the same spreadsheet. So there can't be something wrong with the query. Can't be something wrong with the formulas. You also, in reality, will be more likely to see something like this, where it's not so clean cut, but rather kind of a mixture of performances. And so still, as the product manager, you need to make a decision on what to do. So why is this happening? Well, this gets into one of my other favorite things to talk about, which is Simpsons Paradox. And so when I'm trying to explain what Simpsons Paradox is, I love to use this example that tries to examine whether or not more money leads to more happiness. This is a totally hypothetical example, by the way. As you can imagine, graphing people versus dogs and looking at how much income my dog has is definitely hypothetical. But for the scenario, or for just purposes of explaining, imagine you look at the data and you see something like this, and you need to answer the question whether or not more money leads to more happiness. Well, a straight line average would tell you that yes, if you look, it's just up and to the right, therefore more money does lead to more happiness. But when you segment by the specific user groups, in this case, people on one side and dogs or Shiba Inus on the other, you notice that the reverse conclusion takes hold, that in both cases, as you go up and having more money on the x-axis, happiness declines on the y-axis. Now, why might this be, or why does this lead to different conclusions? Well, there's just some external factor or some confounding variable that leads dogs, in this case, to have more money and more happiness that has nothing to do with the question at hand. Now, why should I care? Or, why should anyone care about Simpsons Paradox? Well, let's use an example that's pretty topical. And let's say you're looking at whether or not a new drug is successful in a trial at treating a fatal illness. And you see this data set. And so you have two analysts, again, scenario of two analysts looking at the problem, where in analyst one says, all right, I'm looking at survivability for each of these cells. And on the top left, we have 100% survivability. So that dog did not die from taking the medicine. So on the y-axis, we have whether or not they got the medicine.
There he is.
Hey,
back, Anthony.
Apparently, internet providers don't like me talking about drug trials during COVID. Let me reshare my screen.
Oh yeah, Big Brother is definitely watching. Cool. Well, I'm glad you're able to hotspot and get back on. I was worried for a second. I wasn't sure if it was me or if it was you. Just the whole thing kind of froze up for a brief moment. But
Right.
Cool. I'm just gonna put myself back on mute and let you pick up where we left off.
And we can see my slides all right? Sweet. So closing this out to recap, hopefully the recap is not going to cause my internet to break again. But analyst one comes in, mentions that survivability is higher across the board for every single user group. But then when you combine them together, survivability is actually lower on average because those who have the medicine have a 40% survivability and those who did not have 60%. So data would tell you, it seems like not to take the medicine. So then what's the better solution here? Notice that if you try to actually look at the data to begin with here, we would call that casting a wide net. If you don't come in with a hypothesis specifically on looking at these individuals and trying to provide a different, maybe your goal is to provide a different approach by user group, we would say that's casting a wide net and then hoping to find the gold in the dirt. So you can imagine running a test on checkout and then hoping that after the fact, you can look at and see which device type performs better and maybe tailor the experience to those specific device types. Maybe, maybe not. The better solution is to segment up front. So provide start with the hypothesis up front to prevent against post hoc storytelling. And what that means is trying to look at the data after the fact as a way to justify or explain what happened beforehand. And so I love to use this little matrix right here for developing a good specific hypothesis, but this is just one of many. I particularly like this because it breaks down the different components that you really should have whenever launching any new feature or launching any new experiment. So you start with the area of focus, or specifically the question at hand. What's the bet or feature that you're making? What do you think is going to be the outcome? For what specific type of user, the persona in this case, and then what's going to be the expected impact? And this is important. I love having this framework because then to the second point in the better solution, you want to have an action plan for each outcome. So for example, if you have one persona have a specific outcome and then another persona have a different outcome, what are you going to be able to do next? Are you even in a state to produce specific personalized outcomes, let's say by device type? If not, then you should be careful about looking at the results with that type of segmentation if you can't act on it. But that's a separate story for another day. So to wrap up, wanted to recap again that making decisions in the face of uncertainty is hard. And these are just 3 out of a bunch of other case studies that we could talk about. But specifically, if you had to print out a slide and take home, or just sip on during the holidays, number 1, focus on the big picture, understanding that even though you're stepping back and looking at the full funnel or the full picture, it's still not an easy thing to do. If it was this, you wouldn't need to attend sessions like this. And then to kind of help provide a good foundation, have good, precise, falsifiable hypotheses. That's the foundation for not just any experiment, but really any feature that you launch. Now, of course, I work for Split, so and I work on the experimentation platform. So I wanted to, I'd be remiss if I didn't drop the plug on our platform and that we help enable all of this to be done for you. So this is a screenshot of our metrics dashboard, where for every experiment you run, you can look at the impact to every single one of your metrics automatically. And we provide not only the statistical analyses and guardrails around, for example, multiple comparison corrections if you're running a lot of metrics, but we provide a lot of helpful visuals, right? Or at least I think are helpful in understanding the impact, positive, negative, if there is an impact. Sometimes you have the inconclusive or neutral impact. But then also we graph over time whether or not your results are getting more precise. And so we have that graph of the kind of confidence intervals or error bars, so to speak. And with that, I'll pause again, but this time actually a meaningful pause, not a internet caused disturbance or breakup, and stop for questions and Q&A.
Thank you, Anthony. Well, that was awesome to hear again. And I loved the pause for dramatic effect with some of the internet issues. It's definitely the most relatable hump day thing I've ever seen in my life. But I have been collecting a couple questions that have been coming into me through your talk, so I can get some started. And if anybody has any other ones, you can send them via chat. You can send them to me in the Q&A box. But so I'm just going to get started. So for those who may have joined a little bit late or want a sound bite to to tell their colleagues what they saw and heard today, what is the TLDR in your words, Anthony?
I would say that's a good question. The TLDR is probably to guess less and test more. That's something that I've pushed not only at Split, but in the years building up to my career here at Split, that what you think you might know, or even when you think you might know your users or what's going to happen, or that you've seen something before and therefore it's going to happen just the same way in your current iteration of your current flow, more often than not, you're more likely to fail than you are to succeed. So the way to control for that and hopefully get better results over time is to take, well, you could still take a lot of bets, but guess less and test more.
That's a great answer. Thank you. Another question that we got is, what is the most surprising outcome you've had in an experiment?
Oh, that's a good one. There are many to pull from. I mean, so these three here, or especially the latter two, I pulled because of the fact that they're surprising. Either they're surprising because the systems are complicated, in the example of the newsfeed algorithm change that looked like it was positive and looked like we had a winning test on our hand, but over time actually performed worse, and we actually just lucked out in not making a bad decision, to, in the last case, seeing results that showed both sides, showed us being right and or the test winning and losing at the same time. So both of those are surprising. But after that, I think there's always, and one of the reasons why I called or titled the talk the way I did on being humble. Even if you run a test 100 times and think that you see a consistent trend over time, you can run the same test later and find something completely different. So as one example, I've run many tests in the nav bar for e-commerce sites and things like that, where instead of having, let's say, 10 options, you have fewer options. And many times you'll see that having fewer options tends to cause people to go more, faster through the funnel. So you'll see funnel velocity increase and higher conversion rates downstream. But ultimately, it's not an intuitive idea to think about having fewer options leading to better outcomes. So that's surprising in itself. But even then, seeing that test maybe 10 times, 100 times, I've also seen it where you get the complete opposite result. So like picking one out of like that kind of grab bag where even seeing the same thing over and over can have like very random results. There's so many opportunities for being surprised, which is also why I love being in this type of work.
Awesome. Thank you. So another question that we have is pretty meta. So what is it like to experiment on a product that's used for experimentation?
That's a good question. It's something that I wish I could do more, but then also need to be a little bit careful. because especially for experimentation product or B2B product, your customers have some set of expectations that they're running their own tests, they have their own workflow, and therefore, if you're running your own tests on those users or your customers, they're probably less likely to want to pay you to continue doing that, right? So I always have to keep in my mind that people are paying me or paying us at Split to provide them this tool that will help them do the experimentation. So in some way, I look at more on I'm enabling others to do experiments and do better experiments. In terms of what it enables me to do on testing on our platform is I also don't know what are the best experiences for a testing platform. I think I know historically what I've seen in other platforms and what other companies do that tend to do well and not do well. So I like to bring some of those into the experience, but then also the industry's changing. We notice that customers are getting really sophisticated in their experiments. There's a lot of historical data, even the science, the statistics, the science, data science, the data volumes, all this, it means that what I think is relevant today is only a hypothesis. And so it's nice to be able to kind of be at the cutting edge of the industry, so to speak, and try to see and feel our way into what's the future of experimentation look like. So like I find that fun, but at the same time, I have to keep cautious, or I have to be cautious that anything that we're testing or any hypotheses that we're exploring, we can't be too disruptive to what our customers are doing because they're already, well, I'll leave it there. Does that answer the question?
I think so.
Okay.
Whoever asked me that, if you want him to elaborate more, just send me a direct message. I'll move on to some of the other questions that we've been getting as we've been going here. Cool. So how long do experiments need to be run to get useful analysis?
That's a good question. And one that it comes up a lot. Unfortunately, you're probably not going to like my answer, but it depends. If you have, for example, one user visiting your site a day, running it for a day is not going to be really helpful because you're only going to get one data point. That's just one extreme, let's say. But the other extreme, you might be like the Facebook or an Amazon where you would get useful results in hours. But then you have the caveat of, all right, let's say you are an Amazon and you run a test for an hour. Are you confident that whatever you're testing is going to give you the right answer in that 1 hour that's going to represent the change you're making forever, or let's say the next few years? Let's say you're running a seasonal promotion and you just happen to be running it during Black Friday. Probably not going to be relevant to your average customer base visiting in, let's say, February. And so there are just a bunch of factors at play and a bunch of variables at play that really make that question a bit tough in the aggregate or in a vacuum. So it's really on a case-by-case basis. That said, there are a bunch of statistical analysis power analysis calculators, that can help you evaluate things like, based on my traffic volume, based on this conversion rate that I'm looking at, how long should I run a test? But even then, I would consider those guidelines because it's ultimately up to you as the product owner, as the engineer, developer, whatever, to really evaluate how much risk you're willing to take. So you might be willing to take on more risk and make a call based on less data. Or maybe you're working on something like a really sensitive financial tool, or you're in the finance space, and you need a lot of data and really want to control your risk and you have a really high risk threshold, then you might want to wait. Instead of like 95% confidence, you want like 99% confidence. So a bunch of factors at play, a bunch of variables at play. It really depends on your case at hand. Does that make sense? Or I hope that makes sense. I can really ask that to whoever asked.
Yeah. Type in the chat if you, looks like you answered the question sufficiently. Thank you, Anthony. Cool. And then we've got a kind of a meatier question here. So something I think has only been mentioned in passing is defining the expectations as metric changes of the experiments. Can you share a bit more about your approach and suggestions about that, and if you see it can help prevent some of the issues that you have presented?
Sure. Can you repeat the first piece of that? Or
yeah, something I think has only been mentioned in passing is defining the expectations as metric changes of the experiments.
Defining the expectation of metrics changes. Yeah, so I might answer the wrong piece of this, or I might answer this in not the right way that you're expecting, whoever asked this. So if that's the case, please keep me honest and respond in the chat. But I believe this is a question around setting up, as part of the hypothesis, kind of an understanding or guess on the impact that you're going to make with your test. So for example, if I have a checkout flow that has a 5% conversion rate, and I'm looking to redesign the entire page, the impact is probably going to be a bit bigger than, hypothesis. This is my hypothesis, at least. The impact is probably going to be a little bit bigger than, let's say, just changing one button color, or the button copy, or something along those lines. And so when you going back to my last question, or my last answer or response, when you're doing the power analysis and when you're doing the analysis on how long you should let the test run, part of that understanding, or part of that analysis, is understanding the level of impact that you expect. And if you're expecting a small change or a very precise change, in general, you're going to need a lot of data to evaluate that. You kind of need a very sensitive kind of instrument. Whereas if you're expecting a wide shift, you can kind of get that pretty easily with a little bit less data. And so I think that's what the question is trying to get at. And usually that comes in with the hypothesis. In fact, if we go back to this page, this is another reason why I love this framework here at the bottom, this table, is that you kind of have an estimation at the end of the outcome impact to that metric. So are you impacting conversion by 2x? Or are you expecting, let's say, improvement in bounce rate by like 5%, or something in that gap? And based on that estimation, and that estimation could come from many different sources. It could come from the size of the change you're making. It could be based on what are called priors, which are kind of looking at an estimate of all the tests you've run beforehand, what you would expect. So for example, if you've run a homepage test 20 times and you're seeing like 5% consistently on average improvement, you can say that, oh, I expect this next test to maybe have a 5% improvement. But that's starting to get kind of, that's if you have a really advanced experimentation program and you're really collecting data. Now, how do we start like that second order improvement question, which I'm also happy to talk about. But
Great.
again, keep me honest if I didn't answer your question.
Oh, looks like you did.
Sweet.
Okay, cool. Well, I think we're actually, that kind of wrapped everything really nicely in a bow for us. I think we're just about at time. So I'm just going to wrap things up here. I just want to say thank you, everybody who joined. Thank you, Anthony, for giving a wonderful talk and for answering all of these great questions that our audience asked. Again, we're going to be sharing out both the slides and the recording. I will make a small edit so that you can jump over that about 2 minute technical difficulty in the middle. We will be in touch. You can expect the recording to come through to you probably sometime tomorrow. Thank you, Sergio. This is a great talk. But until then, I'm Maddie. This is Anthony. And we will be back in touch for another webinar sometime soon. If you have the opportunity to take some time off for the holidays, I hope that you get some time with your family, whether that's virtually or in person, but we will see you next time. Thank you, everybody.